Hey everyone, we're in Houston. We got a little surprise for you, so stay tuned.
Space Center, Houston.
That's where we're going! So what you're seeing ahead of you right now is the actual 747 that carried the shuttles back to their home base after they landed at Kennedy Space Center. This is the real 747. The shuttle on top is actually just a mock-up though. We'll go inside it here in just a little bit. That ahead of us is the Johnson Space Center in Rocket Park, which we'll go to in just a minute. My camera is zoomed all the way out, guys, just to show you how massive this shuttle is. This thing is massive. The wind's moving the turbine on the engine. That's how windy it is out here right now. So we are now inside Space Center Houston here. Today, you can meet astronaut Clayton C. Anderson. It's Saturday, December 23rd, by the way.
Here to the White Flight Control Room, also known as Mission Control of the 21st Century. The room that you see before you is the exact same room we will be using for our upcoming Orion missions going to the red planet of Mars around 2030-2045. Pretty exciting, right? Now this room opened up back in 1995 when we controlled the last half of the space shuttle missions outside of this room, starting with missions SPS-70 and then completing the space shuttle mission with SPS-135 back in July of 2011. After that, we had shut down the room, gave it the major update that it needed. We then controlled the International Space Station outside of this room for 3 expedition missions, while its room is getting the exact same update. Looking over here to the far left wall, you'll see all the mission patches that we have successfully flown out of this room. And then looking over toward the right, you'll see the 3 expedition missions in the upper left-hand corner. Now, if you look on those TVs to your left and right sides of the room, you will see a live image from the actual International Space Station Mission Control Room just right down the hallway from us. Looking inside of there, as you can see, it does look fairly similar to this room in here, except for the fact that it's a little bit more spaced out up there and they have Christmas hats on all of the times. Yeah, as you can see, it does look fairly similar, and they did that on purpose. Normally, Monday through Friday, this room before you is being used as a classroom. Hopefully one day be invited into the International Space Station Mission Control Room. They perform simulations inside of here to test everybody's ability to ensure they are able to work as a team under pressure and to ensure that they are suitable for the job. Now, there's no application to get into this course. You do have to be invited to get into this classroom, but once you are, you're in this classroom from anywhere between 6 months to about 5 years before they feel that you are ready enough to go inside of the real mission control room. Of course, it just matters on which room or which module that you would like to work at. Also depends on your background as well. Now, there's no pilot on the International Space Station. They don't fly it from up there. They fly it from completely in that room in there. So this room kind of allows us to see who is the best of the best because you actually have lives in your hands. Right now there are 3 astronauts on the International Space Station. We have 1 American, 1 Russian, and 1 Canadian astronaut up there today. And their lives are dependable on the men and women working inside of that room. So of course at that time you'd only want the best of the best. But we can kind of say that there is sort of a pilot inside of that room as well as this one in here. And that would be the flight director. Looking in the middle on the second row, you'll see the flight director. And this person controls the International Space Station entirely, controlling the mission, the current expedition mission, as well as the International Space Station, determining its altitude and everything of that nature. So of course we can kind of say that they are the manager of the International Space Station. Now this person holds so much power over it that if the president was to come into this room and try to change something about it, they can legally say, "No, Mr. President, I would not like to change this about my mission. Please exit the room." And it has happened before. Now, another thing that you have to realize on the International Space Station is communication. So if you look right next to the flight director, you will see a desk. Well, if the flight director is the most important person inside of here, why don't they earn that right to talk to them? Well, they do have to make sure that the safety of our astronauts is our #1 priority. Making sure that our experiments are getting done and to ensure that the ISS is safe. You'll see BME and surgeon. BME is the biomedical engineer and surgeon is a doctor with a flight engineering degree. These people make sure that the health of our astronauts is 100%, telling them when to eat, when to sleep, when to wake up, when to work out, when to take the supplements that they need to take. So they often refer to this group of people over here as mom. So every time that they need to know when to eat, sleep, work out, or anything of that nature, they'll call CATCOM and say, "Hey CATCOM, what is mom, what is to do next?" They'll talk to either BME or surgeon, get that schedule for them, and then process to Now, every 3 months or so, we'll send up either cargo or astronauts to the International Space Station. Cargo, which include food, fresh water. Fun fact is that we send about 100 pounds of tortillas every 3 months to the International Space Station due to the fact that they cannot eat actual bread up there due to the amount of crumbs that it produces. So every time that they want to eat a peanut butter and jelly sandwich, it is substituted with a tortilla. Now somebody has to monitor that capsule. It can't be Capcom because they are especially just talking to the astronauts. It can't be BME or surgeon, they're monitoring their health. It can't be the flight director because they're monitoring all those 3 factors. So that's this desk right over here. The VVO being the visiting vehicle operator. Now if you look directly in front of the flight director, you will see a desk that says Ethos. This is the Environmental Thermal Hazard Operations System. And these are the people who monitor the environment around the International Space Station, as well as inside, making sure that it is pressurized and it's a nice warm 72 degrees. So of course, in a matter of about 15 minutes with the speed that we are traveling at, which is about 17,150 miles per hour, traveling at that speed, that means in a matter of 15 minutes, you can go from temperatures from -250 degrees Fahrenheit all the way up to plus 250 degrees Fahrenheit, depending if you're on the night pass or on the day pass. So like I said, in a matter of 15 minutes, the butterfly with 4 wings. Well, in this case, it does have a red ring around it, not sure why. But if you look toward the southern portion of Africa at the moment, toward the bottom of their trajectory, toward the western portion of Australia, you will see that little small icon of the ISS. Now, it does look like it's moving pixel to pixel, but it's actually traveling at that speed of about 7. The International Space Station has already went 2/3 around the Earth. You'll also see live feeds and live images from the International Space Station at this time. You are experiencing a sunset at the moment, so you can see our 24/7 365 on NASA.gov as well as YouTube Live. If you ever go to see that and if it shows a black screen, no worries, give it about 10 to 15 minutes. That means that we are either on the night pass of the Earth, which we are about to push now, or we're just lost communication with the ISS. So not that big of a deal. Just give it about 10-15 minutes and you'll be able to see the beautiful Earth from about 220 miles above. So with that being said, ladies and gentlemen, we are just running a little short on time. I would love to talk to you about everything that I know about this room, but I do unfortunately have to send you on your way to your next stop being Rocket Heart. At this time, if you can be inside of here, so we can once again please keep your distance down. Also, please make sure when you do exit the building, please return to the same seats on the tram. Thank you all so much for coming and enjoy your day here at Johnson Space Center. Thank you.
This is the Saturn, one of the Saturn V rockets used to launch the Apollo spacecraft. And yes, this thing is the entire length of this building we're in. And the fin's way up there.
We do 1, 2, or 3.
The white part is stage 1. See where it breaks? Right there.
I'm going to do
And then there's a blue bit.
1, 2. And this is Mom. So many astronauts together. Whoa! Mom, this is 1,000.
So this, alright, so this is a two-stage rocket. This in the back is the first stage. And we're gonna come back and turn this way. And the first stage is over this way. Let's go take a look at it. And that right there is how they move the rocket around. One of the driver's seats. And this is the second stage. So that's stage 2. It's a 3-stage rocket. There's stage 2 right there. And we're gonna zoom back over, pan the back over this way. Stage 3. Just how big this thing is, guys. Alright guys, this would be the command module or the lunar module and command module sitting right here. And this would be the very front of the rocket right there. Give you a perspective. Look all the way back down here. That's how big this is. The other end is back down that way. Here's what the inside of it looks like. Get press pennies. Space Center, Houston. International Space Station. Astronaut. So the mission control we showed you earlier in the video will be the mission control they use when they send people to Mars. Pretty cool. They said Mars between 2030 and 2040, I believe, is when they're trying to send someone to Mars. The current weather on Mars, sunny and 12 degrees Fahrenheit, I believe. No wind. This whole section we're showing you right now is on Mars. That's their next mission they're fixing to start up. So Mars has 2 moons. You'd weigh less on Mars. Earth and Mars, similar tilts in their rotation. I don't know, that looks pretty roomy in there. Oops. So this is a replica of the new spacecraft, the Orion spacecraft. Actually looks a lot roomier than the Apollo ones.
This is what they look like when they're going out in the water.
That's the whole capsule that we can see back there.
This right here is the Space Launch System, which is going to be how they get the Orion capsule behind us to space. Like, it's similar to what they used to launch their space shuttle. 2 rocket boosters and a external fuel tank. This is the external fuel tank, and then the 2 rocket boosters on each side.
Well, this is just a scaled down size. So see if there's a person. This is a liquid cooling garment worn on the International Space Station to keep the astronauts cool. The shirt you're seeing right now is worn by Dick Covey, who was the first pilot of the STS-26, which was the first shuttle after the Challenger disaster. His crew is known as the Loud and Proud crew. They took these shirts into orbit as a tribute to the thousands of people who put the love and energy and dedication into making space travel possible.
Welcome to Space Center Houston, and welcome to my little show. Yes, it is rocket science. My name is Steven. I'm the mad scientist in the building. There's always at least one, and there can only be one. Now, before I get into the show, there are a few things I do need to go over. First off, if you are looking for Mission Briefing Center and the astronaut presentation, that is actually across the building from us in that direction. Figured I'd highlight that. That happens pretty regularly. Oh good, you're all here. Experiments are exceedingly dangerous and performed by a trained professional. Please do not attempt them at home, or a friend's home, or an enemy's home, or an in-law's home, or an ex's home, or an ex-enemy's home, or an ex-friend's home, or an ex-in-law's home, or any other location you can think of. Do not try them with a mouse. Do not try them in the house. Do not try them here or there. Do not try them anywhere. I think I covered all of it, right? There you go. Okay. Good, the lawyers aren't on my back. I love having guests here of all different walks of life, but I really don't want to meet a lawyer anywhere but here. Okay, so with that out of the way, let's actually get into the show. Behind me is a picture of Robert H. Goddard, the father of modern rocket science. Before Robert Goddard, there was only one type of rocket on planet Earth. We still use them, particularly in months starting with the letter J, especially during the first week of said month. You guys know what I'm talking about, right? Fireworks, I heard it in the back there. That's right, fireworks. Who wants to ride a firework into space? Good, probably not, right? You don't want to ride a firework. What do fireworks do? You begin with ABC, and when you do rocket science, you begin with a dude on screen behind me. What's this guy's name?
Isaac Newton.
Newton, that's right. Think Newton. No. Sir Isaac Newton. Now, Sir Isaac Newton lived a long time ago in a land far, far away. This land's name was England. I'm sure you've heard of them. At least something about a tea party in Boston, right? Yeah. This is Sir Isaac Newton. He lived a long time ago in Great Britain, in England more accurately, and came up with a lot of things that are really important to NASA. Things like orbital mechanics. That's the fancy math that NASA uses. By the way, he also failed orbital mechanics, so if you're bad at math, don't worry, so is the mathematician who invented it, most likely. That's why they invent it. They just want to find a way to cheat. That's how it works, right? Second thing he came up with that I'm sure you've heard of that we really need to know in NASA, the law of gravity. That one's a bit of a downer though, so I'm not going to dwell on it. He also came up with the 3 laws of motion, the most important of which for NASA is Newton's 3rd law of motion. What is Newton's 3rd law of motion, by the way?
Action, reaction.
Action, reaction. For every action, there's an equal and opposite reaction. I need a brave volunteer to help me demonstrate Newton's 3rd law. Education department here. I do know the teacher tricks. All right, welcome to the stage, sir. Go ahead and put on those totally not mind control safety glasses. All right then. What's your name, by the way? Mike. All right, Mike. Wave hello to the audience. There you go. Put your right hand in. Put your right hand out. Put your right hand in. Shake it all about. Good, the calibration's done, and that's what it's all about. All right then. So, we're going to be demonstrating Newton's 3rd law of motion using a stomp rocket. All you're going to have to do, Mike, is stomp on the pink pad. But first, there's a couple things we need to do. We're going to give the audience a pop quiz. Audience, what is the action in this experiment going to be? What is the action? The stomp, that's right. What's the reaction going to be? Liftoff. And what do you do before you launch a rocket? A countdown, that's right. Guess what your job is, audience? Countdowns. We're going to start from 3. We're going to make that the standard through the entire show. Okay? Here we go. T-minus
3, 2, 1.
That's tight.
Woo! Working. Flip it.
No.
Pop it. Twist it. Oh, wrong side of the match you meant, right?
Yes.
There we go. Ooh, might make fire. There we go. This, ladies and gentlemen, was an object lesson in direct objects. This part of the show is brought to you by English majors, because we have to do something with grammar Nazis. All right then. This is a lit candle. We lit a match. So what was special? Want to see an exercise disappear? All right, abracadabra. Unfortunately, all my nitrocellulose has actually disappeared, but I do actually have security footage of what happened to it. You guys want to see what happened? Yeah, okay, here we go. Yeah, that would do it. I mean, seriously, we burned through this stuff. There it goes. That stuff is a favorite. Behold, my favorite stuff. This is lycopodium powder. Lycopodium powder comes in jars like this. Has a massively long warning label. That's all just warnings on how flammable this stuff is. There's a reason I like it. In fact, it's so flammable, it has got a name from actually stage show people, such as myself and also special effects artists. It's called Dragon's Breath. I'm holding a jar of Dragon's Breath. That makes me sound like a wizard, doesn't it? I can teach you to ensnare the minds and entrap the senses. 10 points from Gryffindor for laughing. 10 points to Slytherin for sharing mirth. There you go. Now this stuff is a favorite of mine. Before the show, I poured some lycopodium powder into this jar right here. There it is. This is lycopodium powder. Hopefully you can actually see the pile of powder in here. I'll try and set it up to where you can see it. If I tilt this much more though, I'm going to dump it all over the floor, and that's a big dangerous mess. There it is. It's that yellow powder. This is made from ground up fern spores, and we're going to burn it. So we've got our fuel. We've got our heat. But there's one more part to a triangle, right? Right now we just have two legs. What else is there in a triangle? Do you think it's oxygen? Well, we breathe oxygen, right? We breathe in oxygen, we breathe out carbon dioxide. So let's mix all three together. Here we go. In 3, 2, 1. That was pretty cool. Coffee creamer coming in? Can't remember. Seen all of them. Okay, there we go. So we're going to go ahead and light this on fire. And this is our solid rocket booster. We've got heat and we've got fuel. In a real solid rocket booster, you actually have the oxygen mixed in, so once you add heat, it would go. So we're going to add in some oxygen now. Here we go. In 3, 2, 1. In case you had any doubts, I'm full of hot air. You guys want to see that in slow motion?
Somebody call 911. Shiny fire burning on the dance floor. Whoa. What's up?
It's pretty. Behold my jet engine.
I see.
Okay, yeah, I know it doesn't look like much. Budget cuts are a thing, unfortunately. This is a working jet engine. This thing is awesome. On the inside, it's got a fuel. This fuel is isopropyl alcohol. Isopropyl alcohol, it's also known as medical alcohol, or rubbing alcohol, or that smelly stuff nurses smear on your arm before they stab you. It's also the main ingredient in hand sanitizer. Who's gotten hand sanitizer in a cup before? Burns, right? Yeah, so we're gonna take some vengeance on behalf of mankind here. So this jet engine's got fuel already in it. I stoked. So we're gonna shake this up. The more we shake it up, the better this goes. Now this is where normally, to stall for time, I can tell a couple of bad NASA jokes. Unfortunately, my joke writer got spaced out. So I'm gonna have to make it up on the fly. There you go, 2 bad NASA jokes. All right then, so we've got our fuel, we've got our oxygen. Let's add in some heat. Here we go, countdown time, audience. 3, 2, 1. That was pretty cool, wasn't it? Oh, go. You'll notice the flame started off a bright blue color before turning right then. There you go, sir. All you have to do is poke the blue balloon. Let's see if helium's flammable in 3, 2, 1. Also gets its name from ancient Greece, where hydro means water and gin means to make or beginning. This makes water. It's the beginning of water. What you use water for when there's a fire? To put it out, right? So do you think this is going to be a good source of combustion? Yes. Why are you saying yes?
The only one real.
Because it's the last one. Okay.
This might.
Alright then. So, we're going to see if hydrogen's a good source of combustion. Here we go. Testing to see if hydrogen's a good source of combustion. In 3, 2, 1. And now a word from our sponsors. Bird. Bird is the word. Have that song stuck in their head now. Alright then, let's test it for real this time. Here we go. In 3, 2, 1.
If any of you have seen Star Trek, this is one of the props from the original series. That's what it looked like before, and that's what it looks like.
By refining the models and test after test, John
This has made the Mod 5. Well, he built radio-controlled lights. And yes, we can actually use the Boeing 747 to separate the spatial awareness to do the approach.
Successful flight models led to test using an actual 747 and a prototype shuttle called
The real surprise was we looked out.
This is how the shuttle is attached to the 747, or how it was attached.
Well, I started over here.
World's first untethered spacecraft, and we sent 2 of our mission specialists outside Bristol campus.
No, it did not. But not very often you get to see a stripped down airplane just to the frame, though.
Okay, test after test. Finally, April 12th, 1980.
And I want to watch this TV.
That up there, flight data recorder and cockpit voice recorder. The black box is in fact not black, it is orange. Do you know that?
The last few years. So.
And this is how they maintain pressure in an aircraft. Or in this aircraft. This is in the tail. Massively big engines on the 747. Now we're gonna go visit the shuttle central compartment, I believe, and then the flight deck. Massively big engines on the 747. Now we're gonna go visit the shuttle central compartment, I believe, and then the flight deck. Getting a close-up of the shuttle, guys. Pretty cool. This is as close as I've ever been to a shuttle. We're actually gonna go in it. Now, this shuttle is a replica. It was not in space ever. We are now in what is the cargo bay of the shuttle. We're gonna go to the flight deck. Thanks to these sponsors. So guys, this is where they would stay or sleep. It's about the size of a small kitchen. And here. They would sleep in a sleeping bag. It's really hard to see though. Lockers.
Acá está. Andábamos buscando el espacio. Por eso vienen a veces ahí. I think they look at them eating spaghetti. Oh wow.
I think it's just peanut butter.
Here's a toilet on the shuttle. And there's my wife on the other side of the toilet. Hi! And this door right here would bring you up to the flight deck, which we'll go up to in just a minute.
up to 8 hours.
And now we're back in the payload area where they would keep everything. And this is actually a rescued satellite. The satellite was actually in space at one time. And look straight up. And turn around. It's the robotic arm. Used to retrieve stuff from space.
You seem to be mesmerized by them.
She had a question.
She was just saying something they were saying. I was requesting can't walk on her. She's I just responded to that.
Pretty tight.
What happened? Does it like that?
They have no window, right?
Yes, they do. Yeah, those are all windows right there.
Alright. What do they, yeah, I
She
guess they
removed
would.
before flight.
Okay, does it have to be this tall?
This is looking from the flight deck down onto the payload area. Those are not part of the space shuttle. Inside Skylab.
And if you see any of them that you see that has like that different colored tape on it, is storing light sensitive film for the telescope over there, and so they know. That's what they would do, right? Besides this low body negative pressure, they did not like this at all, but they would have to sit in it because since there's no gravity, the blood doesn't flow properly, and so that would make sure that the blood is. See, the sleeping bag is down there. They didn't sleep on stuff like that. They have them down underneath there.
Well, the advantage of being in zero gravity is that you can let your whole body relax.
This area right here is where all the trash would go. That has a all
So when they're in space, they can like float around and
Well, we hope you enjoyed that video of Space Center Houston and Johnson Space Center. We will be hopefully going back to do the other half of the tram tour, which we did not get to see this time. The tram tour we did this time was just of Mission Control, which is the current one being used today, as you saw in the video. However, there is another one that shows, I believe, some training areas, which we'll do next time. The only reason we didn't do it was due to time crunch, and the wait for that tour was about 2 hours long. We do plan on going back eventually to that area. My parents live in Houston, so hopefully we'll be starting to go there a little bit more often. Please join us for our next video. We may be doing some stuff around our hometown of Lubbock, Texas, just to show you what there is to do here. Texas, it is a very big state, so we'll put as much as we can in the video, but it's going to take a long time to show you what we want to show you in Texas. So don't forget to click like and subscribe and hit the bell icon to be notified of our next video posting. Have a great day, and remember, no bad days.